The half-life of radium is 1690 years. So half-life means if we start with 1 unit of that radium, then in 1690 years it's gonna go down to 1/2 units, like 1 grams to 1/2 grams. So from this we can find the decay rate. Okay, then the second part, if 10 grams are present now, how much will be present in 50 years? So that's the second part after we find the decay rate from the first. So half-life is given this. So in this exponential decay, we know the formula AT, amount after some time, is given by A naught, initial amount, times e raised to k, that's the rate, decay or growth rate, kt, time t. So in the first part, this initial amount, okay, this initial amount is 1, we can take 1, and this will be 1/2, and the time t is 1690. From this we can find the value of k, that's the decay rate, and that has to be negative, and we use the same k to answer the second part. So let's do the first part. So the final amount is 1/2 equals 1 times e raised to k, to be determined as times 1690. So 1 times this is just that, this one does not count. Now we take natural log both sides to get rid of this exponential. So ln of 1/2, this is a negative number by the way. Natural log of 1/2 equals, when we take natural log and e, they cancel, their actions cancel, so we are left with k times 1690. Now divide both sides by 1690 and we get k. So k equals ln 1/2 divided by 1690. Okay, we can write the approximation in decimals, but use a lot of decimal places. It's going to be negative 0.00041014626. Okay, so that's the decay rate. It's very slow because in 1690 years it goes to 1/2 grams from 1 gram. Now for the second part, we use the same formula. So here the initial amount is 10 grams and we want to find how much will be present in 50 years. Okay, so we want to find this final amount, that is A after 50 years. Okay, that's AT equals, initial amount is 10 grams, 10 times e raised to k. K is this decimal number. I'm just write k for now. K times t is 50 years. Okay, 50. Now we use our calculator and find approximation. This is 10 times e raised to k. K is this, or better you can write this fraction. In fact, k is this negative times 50. Use your calculator, you're gonna get 9.797 grams. That's grams. Okay, this is amount after 50 years final. So here these are short questions. Find the exact value. So here we got e raised to ln 2. Okay, so e ln 2 means e and natural log, their actions cancel, 2. That's it. Same thing, 3 ln log 3, their actions cancel, just 5. 10 log means log 10, 10 log, their actions cancel, this is 15. E ln, their actions cancel because natural log and exponential functions are inverses to each other. E ln adjacent cancel, just x plus 2. 2 log 2, but this 3 is here, so we need to get rid of this 3. This is 3 as a product in front of log, so 3 goes here, so we can rewrite this as 2 raised to log 2 5 raised to 3. Now 2 and log 2, their actions cancel because they are adjacent, so that leaves 5 cube, that is 5 times 5 times 5, 125. Again log 5, but there is a 2, so this 2 goes here. 5 log base 5, 3 raised to 2. 5 and log 5, now their actions cancel. This is 3 squared, which is 3 times 3, 9. Log 5, oh, there's negative 3 here. Log 5 and 5, their actions cancel. This negative 3 comes to the front, by the way. This one just jumps to the front. Negative 3, and we have log 5 of 5, which is 1. It's negative 3. Here cube root means, let me rewrite in this way, log 2, cube root of 2 means 2 raised to 1/3. Now this 1/3 jumps to the front, and log 2 with base 2, that's 1. So this is just 1/3. Same thing here, ln and e, their actions cancel. 3 jumps to the front. So the answer is 3.